So today we're continuing our analysis of series circuits. Again, series circuits are ones where if our current or if the electrons in this circuit are moving, and in this one they're moving pretty slowly, but if they move through this 35 ohm resistor, then they have to keep going through this 38 ohm and 10 ohm resistors. There aren't multiple paths that these electrons could travel where we get into parallel circuits or parallel paths, which we'll talk about next week. But in a series circuit, today we're looking at voltage drops through each of these resistors. So just as a reminder, voltage is some difference in electrical potential. It is not the same thing as electrical potential energy, but it is correlated with electrical potential energy, just like height isn't the same thing as gravitational potential energy, but the higher an object is, the more gravitational potential energy that it would have. So today, I'm just going to go over quickly how to use these voltmeters because we haven't used them, not in any work that we've done before have we used these. So for these voltmeters, you'll notice we have two terminals or two leads, and the technical order that you're supposed to use these in is we would put the red terminal here slightly further upstream or sort of like earlier in our circuit. So if these electrons, and it'll be easier to see if I turn this voltage up a little bit so that we can actually sort of see these electrons moving. But we would put the red terminal of this sort of like upstream in this, or by upstream I mean sort of before this resistor. So I'm going to put this sort of like the metal end of this red terminal on the wire before this resistor, and then the black end of this at the sort of exit there, and this will give me a voltage, and you can notice that this voltage is negative. That is because we have a voltage drop across these resistors. These electrons have a lot of energy coming right out of the battery, and then lose some of that energy, even though they're moving at the same speed. It looks like they're losing some of their electrical potential energy as they move through these resistors. So that's why if you do this way, you'll get negative values. That being said, if I turned these terminals around, or if I turn the leads here around, I still get the same 17.5, just now positive instead of negative. All of the answers that I'm writing in the work for today, and that I think I'll do in the foreseeable future, I'm just going to use the magnitude for these voltage drops, because when we use Ohm's law, there are no negatives or positives, but it's important for us to know still that through these resistors, the voltage is dropping. The electrons are losing some of their energy as they move through a light bulb or through whatever practical application we have for our circuit. And today you're measuring these voltage drops across each resistor individually. So basically to do that, I would have to move my terminals for each of these resistors. So I would put it sort of around either side of this resistor. I got 19 volts. Let's do the same thing here. And across this last resistor, about a 5-volt drop through that last resistor. And you would do that for your circuit, which has a different voltage for this battery. So just as a reminder, you can change those voltages with this little slider if you click on the battery, and then you can change these resistances by clicking on those resistors and using this slider just like that.